Okay. So next point of our syllabus, that is configurations of diastereomers on the basis of physical and chemical methods. So in physical methods, number of methods are there. So with the help of these methods to determine the exact configurations of diastereomers, that is diastereomers means it is cis or trans. With the help of these methods to study the exact configurations of unknown compounds, cis and trans. What is meant by cis and what is meant by trans? Cis means that is the highest priority group or lowest priority group which is present on same sides. So this is called as cis. It is nothing but the jets. Second one, that is trans. Highest priority group presents on opposite sides, or lowest priority group which is present on opposite sides. So this is nothing but the trans. So this is nothing but the E configurations. So with help of these methods, we are going to study the configurations of diastereomers. So first point, that is dipole moment measurements. So with the help of this dipole moment measurements, with the help of these measurements, you are going to study the configurations of diastereomers. So if you consider the example, that is 1 chloropropenes. Example, that is 1 chloropropenes. This is their cis form. Another, that is trans form. So this is their trans form. So if you consider another example, that is 1,2-dichloroethanes. H, in this here Cl, double bond H, Cl. This is their cis form. Another, that is trans form. This Cl, this sides H, and Cl. So 1 chloropropenes, another example, that is 1,2-dichloroethanes. So this compound, out of these two, which compound is cis and which compound is trans? So if you consider this compound, there is 1 chloropropenes, so this is the cis. Because of the, if you consider their dipole measurement, so their value is, if you consider another example, this compound, their value is 1.75, and trans, their value is 1.85. If you consider this 1,2-dichloroethane, so in that case, there is suppose this halogens, same halogens is present in the compound, so at that time, there is in that compound there is a trans form, they do not show any dipole value. That is nothing but that their dipole value is 0. If you consider cis example, so they have some dipole values, and so their dipole value is 1.60. So near their 1.60. So in this two, that is if you consider example that 1 chloropropenes, their cis and trans form. So the cis form, they have the less dipole value. If you consider the trans have the more dipole value. If you consider other example, that is 1,2-dichloroethanes, trans form, dipole value, they do not show the dipole value. But cis form, they show some dipole value. Their value is also given here. So this is the first measurement, that is the dipole measurements, and so on the basis of these dipole measurements, we have determined the exact configurations of diastereomer. This is the cis, this is trans. Because of trans have the more dipole value, cis has a lower dipole value. If you consider example, that is 1,2-dichloroethanes, this is their trans form because of 2 chlorine group is present on opposite side. That is the highest priority group or high molecular weight which is present on group group of atom which is present on opposite side. So this is nothing but the trans. Same side, this is nothing but the cis. But this same halogen present in that compound, so that compound do not show any dipole value, and so they show the 0 dipole value, and so cis they show the some dipole values. So this is the first measurement, that is the dipole moment measurements. Second point, that is comparisons of boiling points. With the help of the comparisons of boiling point to determine the exact configurations of diastereomers. So by using the formula of measurements of boiling points, so the formula is Tx is equal to T naught plus summation A. Tx is nothing but the calculated boiling point, T naught is nothing but the boiling point of parent compound, plus summation A is nothing but the different substituent present in that compound. So you have to consider 2 examples here. First example, that is 1,2-dimethyl cyclohexanones. Example, that is 1,2-dimethyl cyclohexanones. If you consider this example, so in this here there is 2 methyl groups is present in the equatorial positions. If you consider another example, in that case there is a 1 methyl group is equatorial and another methyl group is axial. So here one methyl group is present axial, another methyl group is present in the equatorial. to calculate their boiling points, and so which compound is cis and which compound is trans, which is conferred on the basis of this. So first there is a axial equatorial methyl groups, equatorial substituents methyl group acetyl their value is 90.1. Equatorial methyl group acetyl. Next, there is axial methyl groups, at that time their value is 23. Then add the increments. Equatorial methyl groups, so add increment plus 4.2. Equatorial axial methyl groups, so at that time to add increments 3.1. Then there is 2 geminal dimethyl groups, so at that time add the increment minus 5.7. So add this value in the formula, and so to calculate their boiling points. So Tx is equal to boiling points of parent compound 81.5 plus, in this if you consider this is a A and so this is a B. So in this here two methyl groups are there, and those methyl groups are present in the equatorial forms, and so therefore 2 into 90.1 plus equatorial methyl groups add increment 4.2, equatorial axial add increments 3.1, and 2 geminal dimethyl group add increments minus 5.7. So in this here 2 equatorial methyl groups are there, so add the increments 4 plus 4.2. So in this way to calculate the boiling points, so at that time their boiling point is 13.9 degree Celsius, so near these values. So in this way, this is the calculated boiling points, and boiling points of their expert value is 1.123.7 Celsius. So in this way, compare this compound is cis or trans. So on the basis of this comparisons of boiling points, we are going to determine the exact configurations of diastereomers by using this formula, and so add the values in that here. Tx is nothing but the boiling points of calculated boiling point, T0 is nothing but the boiling points of parent compound, that is 81.5, and summation A is nothing but the presence of different substrate in this here. So in this here 2 substrates are present, both are equatorial, so at that time I add the value that is 4 plus 4.2. Suppose at that time one axial, another equatorial, so at that time to add the value that is 3.1. 2 geminal dimethyl groups, so at that time add the value that is minus 5.7. Okay, so in this way we are going to compare the boiling points of these compounds, and so on the basis of this we are going to determine the exact configurations of diastereomer. So in this way, another example there is in this here. So in this here one methyl group is equatorial, another that is axial, so their parent value is 81.5. Then next equatorial value is 90.1, this value add in this here. Another methyl group which is present in the axial, so add their value that is 23. Then add increments, there is 3.1, because one equatorial axial methyl groups at that time to add the value that is 3.1, and so at that time to calculate the boiling points, and so compare their experimental value, and on the basis of this to determine the exact configurations of diastereomer, so by using this formula. So next point, by using the EV visible spectrometer, with the help of the EV visible spectrometer, that is EV visible spectroscopy, and with the help of this spectroscopy to determine the exact configurations of diastereomers. So if you consider example that is a steel beam, their cis form and their trans forms. So cis form their value and trans form, both the compounds of value compares, and so at that time to determine the exact configurations of diastereomer, which compound is cis or which compound is trans. So suppose if you consider this is steel beam, another so this is the trans compound, this is the cis compound. Trans compound, their value is 295 nm. This is the lambda max value, which is calculated by using the e-visual spectrometer. Another that is cis isomer, which their value is 280 nm. So on the basis of this two value, we conclude that that is a trans, they have the higher e-visual value, it is 295 nms. If you consider the example that is cis isomers, so this is isomer, they have the low value. So on the basis of this visual spectroscopy, get the data, and so on the basis of the data, we are going to determine the exact configurations of diastereomer, that is trans have higher e-visual value, that is e-visual value, and so there is the next one that is cis, they have the low value. So on the basis of this, we are going to determine the exact configuration of diastereomer. Next point, by using the X-ray and electronic diffractions. X-ray and electronic diffraction, they give the informations about, there is a distance between the various group ion atoms. And so they give the good results, and so on the basis of this result, we are going to determine the exact configurations of diastereomers. So this is about X-ray and electron diffractions. So next point, by using the mass spectroscopy, with the help of the mass spectroscopy to determine the exact configurations of diastereomers. So if you consider any example, there's cis form or trans form. Suppose if you firstly consider the cis form, and this cis form compound which is put in the mass spectrum instruments, and so high energy electron beam is bombarded on that molecules, so it undergoes the fragmentations, and so there is formations of molecular ion fixes take place. So cis form, in that compound there is a there is a molecular ion fix. Then you use the transform, that compound put in the mass spectrums to bombard the high electron beams, and it undergoes the fragmentations, and there is formations of molecular ion fixes take place. So you get the peak between the cis isomers and trans isomers. So trans isomer, they have the in that case there is formations of molecular ion fixes take place, but they have the high intensity. If you compare the cis, they have the low intensity. So on the basis of these two, we are going to confirm, or we are going to determine the exact configurations of diastereomers. That is, in the trans isomer, they have the high, we get the high intensity of fix in trans isomers, but in cis isomer there is we get the low intensity of fix, and so on the basis of these two, we are going to confirm the exact configurations of diastereomers. So next point, by using the NMR spectroscopy. In the NMR spectroscopy, first one, that is chemical shift, another point, that is coupling constant. Chemical shift means what? There is a shift of proton from peak of TMFs. This is nothing but chemical shift. Coupling constant is nothing but the distance between the two. दोन पिकच्या मधला अंतर त्याला coupling constant म्हणतो. तर on the basis of these two, so by to compare the value of cis and trans, their chemical shift values. So we are going to use the first, that is Stilbene example. Same. So in that compound, this is the trans form, another that is cis form. Compare the chemical shift value. So trans for this carbon show their chemical shift value is 7.85. In this here, consider this carbon having hydrogen, they show the value 6.35. So this is the cis, this is a trans. Trans have the high chemical shift value. So on the basis of this, we are going to confirm the exact configuration. This is nothing but the trans. In this here, cis have the low value, that is 6.35. So on the basis of this, we are going to confirm this compound is cis. And so this is the, by using the chemical shift to determine the exact configurations of diastereomer. Another point, that is coupling constant. So in coupling constant also same, the compound have the high chemical coupling constant value. This is nothing but the trans, and those compounds, they have the low chemical coupling constant value. This is nothing but the safe. If you consider example, that is 1 chloropropanes, another that is 1 dichloroethanes. So 1 chloropropanes, if you consider their cis form, this is cis form, another that is the trans form, highest priority group which is present on opposite sides. This is nothing but the trans. So their value is 11 hertz. Their coupling constant value is 11 hertz. There is a 16 hertz. If you consider another example, there is 1 dichloroethanes. So in that compound also, this is their cis form, another that is trans form. So their chemical coupling constant value is 5.3. Their coupling constant value is 12.1. So in the trans form, their coupling constant, they have the high coupling constant value if you consider the cis form. And so on the basis of this, we are going to determine the exact configurations of diastereomer. These are the physical methods. Next point, in this here, there is a chemical methods. So in a chemical methods, there is a functional group which is present on the same sides. So at that time, there is ring formation reaction which takes place. But it also undergoes the ring opening reaction. So at that time, there is a functional group which is present on the same sides. But in case of trans, there is a 2 functional group which is present on opposite sides. So at that time, there is no ring formation reactions take place. It does not undergo the ring opening reactions. So this is the those compounds which take place. There is formations of ring opening and ring closing reactions. This is nothing but the cis. and in that compound there is no formations of ring opening or ring closing reactions take place. This is the trans. If you consider the example that is cumaric acids, which is converted into the coumarins. So in this case there is a two functional group which is present in the same sites. So in this here, this COH, OH, this two OH group which is present on same sites. So in this here there is a ring closing reaction is take place. So in this here there is formations of cumaric acid into coumarin. So in this way this coumarin is formed. That is nothing but these two functional groups which is present on same sites. So it undergo the ring forming reactions. Suppose it undergo the retro. So at that time there is a formations of two functional groups on same sites. So it undergoes the ring forming and ring opening reactions in a cis. But in trans, suppose this OH group is present on above. So in this example, this OH COH group present here, so methyl group is present here, and so in this example there is no formations of ring forming reactions which take place, and so in this way this is nothing but trans, this is nothing but the cis. So on the basis of these two, we are going to confirm the which is trans and which is a cis by using these chemical methods. So if we consider another example that is 1,2,1,3 dicarboxyl acids cyclohexanes or 1,4 dicarboxyl cyclohexanes. So in that example, so this is the example of, this is the position number 1 in this here, one COH group is present. This is the 1,3 dicarboxyl cyclohexanes. Another example, 1,4 dicarboxyl acids. In this here COH group is present, and so in that two example there is formations of anhydrides take place. In this here, this example there is formations of anhydrides take place, means these two OH group which is present on same sites. So therefore in this here there is formations of anhydrides take place. So this is another cis. In this example also there is formations of anhydride between this COH group and this OH group. In this water molecule is removed and there is formations of anhydrides take place in the 1,4 and 1,3 dicarboxyl acids. So this is but this is the cis. Trans means this OH group presents on below. So at that time there is no formations of anhydrides take place. That is nothing but ring forming reaction does not take place, and so therefore this is a trans. So this is the chemical methods, and with the help of this chemical method we are going to determine the exact conformations of diastereomers. Okay.